we always want to make sure, and I'll keep reminding you of this every time we do this, you've got to make sure your lines are in y equals form. And to kind of go along with that, let's take it a step further and actually make sure that we've got things that are in the right format. So, if I notice here on numbers 1 and 2, and actually several of them, I don't have y by itself yet. And unfortunately, whoever was putting this together, oh wait, that's me, wasn't thinking about giving you enough space necessarily. So here's what I'm going to do. I'm going to show you in this kind of separate area here how to get y by itself, and then we'll actually just write above and below the line here what our equation's going to be. So for instance, on this one, I've got x plus y equals 4, but I need to make sure that y is on a side by itself.
Why do yours look like that?
So, because I put a little slip of paper on here so you can kind of see what I'm up to. So what's my one step I need to do to get x by itself? To get y by itself. Whew. Yeah, I'm going to minus that x to the other side. So when I look at that, I say, okay, so y equals, I want to watch the order that I write things in when I'm doing this, because I always want the term that has x to come first. So I'll put the negative x first, and then the b is just the plain number. So this is what my line A is going to be when we go to graph it. Okay, so negative x plus 4. Once I've got that one done, I'll just go ahead and do both of them while we're here. So for B, I have a slightly different dilemma. I still need to get y by itself, but now I'm multiplying it by 2. What's the opposite going to be? How do I undo a multiply by 2? Divide it. Okay. And I've got my y by itself. So sometimes I may have to do a little bit of side work on these. A lot of times you'll notice on the homework I already have them in y equals, because I really want you to just see how that goes. But getting a variable by itself helps. So when I get here, I'm ready to graph this. And here's why I wanted you to grab the colored pencil. Because the first one, we're going to go ahead and do just graphing normally. So when I do these, I always want to graph my y-intercept first. Whatever that number is on the end is going to go somewhere on here. So when I do this, my y-intercept for my first one's at 4. So to get to 4, I'm going to go up 4 and I'm going to put a point. That first point's always going to be somewhere on that line. But here's the question I've got. What number's in front of x here when I don't see one? 1. So my slope here is really negative 1 over 1, because we want it to be a fraction. So now comes the important part, of course. What's that negative 1 over 1 slope mean? Perfect. It means I'm going to go down 1, and I'm going to go right 1. And like we started talking about yesterday, we're basically going to make our whole line out of dots. We're going to keep going down 1 and right 1 until I run out of room. Now, those of you that weren't here yesterday might be saying, okay, why would I want to do that? This is kind of crazy. Because we want to be so accurate with our lines, because if they do cross at a point, I don't want to miss it because I got sloppy when I draw my lines. I mean, I've been doing this for years, and I still get sloppy when I draw my lines. So, okay, so I kept going down 1 and right 1 until I ran out of space over here. But we also talked yesterday about what happens if I run out of space. Can I keep it going the other direction? And I can. So if I've been going down 1 and right 1 to make all these dots, and I wanted to keep going to the left, what could I do to keep going? Okay? Yeah, I can do the opposite of each of these. So instead of going up 1 and right 1, I could go, oops, down 1, Harty, 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 down and right. I could go up and left, and I would stay on the exact same line. So basically I made an entire line out of points. Once I've done that, my job is to do the same thing with the other line. So I'm going to take my y equals 3x, and if there's no number on the end here, we're going to work it like it's just 0. So my y-intercept is that number that's on the end. It's still at 0. And I'm just going to use my other color now so I can kind of see what's going on here. What's my slope then for this line? 3. And in this case, 3 over 1. Because if it's not a fraction, I'm going to make it 1. Let's see if I can actually write this correctly this time. So we're going to go 3 up and 1 right. So up 3, right 1. Ooh, bingo already. Up 3 and right 1. And somebody may be saying, do I really have to keep going? I already see where the point is. I'll just put a couple more dots here. Once I see where that intersection is, where my two different lines connect with each other. In this case, it's right there. That's my answer. That's what I've done all of this for. So I'm like, okay, so where's the point of intersection at? Well, let's see. What point is that? I go right 1 and up 3. How would I write that as my point? If you go right 1 on x, is it positive or negative? Positive, okay. And then if I go up 3 for my y, is that positive or negative? Positive. So that's my answer. That's what I worked through for all of this. Now, like I was saying before, once I get it into y equals, and this is why I wanted to get you the calculators in your hands here, and I forgot to open up mine to get mine in my hand, you can actually, once it's in y equals, let the calculator help you figure out where the intersection point is. It's kind of cool. So here's how it would work if I do it this way. And I'll do it on a couple of these. Some of you may say, yeah, I don't want to play with those. So here's what I would do. I'd go to y equals, the button up here in the left. And what I'm going to do is I'm going to take these two equations, I'm going to plug them each in. So I'm going to do negative. This funky button here that has x and a bunch of other stuff on it, that's actually my x. So negative x plus 4. And then I'd arrow down, and I'd put my other equation in there. My 3x plus 0. And what the calculator will do is, if I want, I can hit the graph button, and it'll draw me a picture, sort of like what we were doing here. But here's the cool thing that it'll do for me. If I want to know where that point is, right there, where the intersection point is, the calculator can actually do this. So here's how this would work. And let's see, where do we want to put this little note? We'll put it right here. If I'm going to do an intersection with the calculator, I'm going to hit second and trace. And then this menu is going to come up where I can find all these different values. But the thing I'm interested in is number 5, intersect. And here's how this works. It's kind of slick. This little blinky guy, this little cursor is going to come up. And he's going to say first curve. Now I know they're not curves, they're lines. But basically what he's saying is, okay, where's your first line? Well, I'm on this one already, anywhere along it. Doesn't matter where. I click enter to say, okay, that's the first line I want you to check for. Then you notice when I hit enter, it changes. And it goes to the other line. And you're like, okay, that's my other line. It's right here. That's cool. And then it said, I'll hit enter. And it'll say, guess And if I get kind of close here, that looks about right. And I hit enter one last time, and notice intersection. X equals 1, y equals 3, just like when I did it on that one. He's not here today. Thank you. So it's kind of cool that the calculator can do some of the work for me. But the one thing I always have to do, whether I'm using the calculator or I'm doing it myself, is I got to get y by itself. Okay, that's going to be my goal. So that's always an option for you if you want to do it with the calculator. If you want to play with it sometime, you want to ask me about it, we can do some together. So, all right. I'm going to have you help me get these two into y equals, and then I will get the rest of them into y equals for you, because the graphing's the big thing I want us to be doing. So, all right. One more setup here. And sometime if you don't have enough room, this is always an option just to kind of get you some space to work with here. Okay. Got everything ready? I think so. So in letter A, what's my one step to get y by itself? Close. I'm multiplying y by 2. What's the opposite? Divide. Okay. So for A, y equals 2x. We'll get that 0 on here in a minute. So then my other one, now I'm adding 3x to it right now. What's that opposite going to be? Subtract it. So that's going to be my second line. So I'm going to go ahead and put that here, because I want both my equations to be looking good for me. So once I have them in y equals, my job becomes pretty straightforward. It becomes, now I got to graph them and I got to see if they cross somewhere. Hopefully they do. We'll see. So let's see here. Y equals 2x. I'm going to add my plus 0 in here. If there's not a number at the end, we'll just always add that in. So my first dot is going to be here at 0. What's my slope this time? 2 over 1. So what's that mean? My slope's 2 over 1. Where am I going? Yeah, up 2 and right 1. And I'm just going to keep doing that. And again, if I run out of room, I just do opposites of both of those. So I'd go down and left. And work that out. So I get this line that goes all the way through, because I want to see any possible dot I could run into here. So I got one more dotted line to do here, like I said, to see where they intersect. Let's see here. What's my y-intercept for my second line? Where's that first dot going to go? 5. So up 5, get me a nice dot with my other color. What about my slope this time? Say that one more time. Close. I think they got a symbol in front this time, though. Yeah, -3 over 1. So how's that negative change my up or down number? Do I go up or down with -3? I'm going to go down 3 and right 1. And already, again, that very first number, there's my overlap. So I'll put a couple more dots in here. But I notice right away, right here, there's my intersection point. So what value does this point have? What's my coordinate point for that? How many did I go over and how many did I go up? 1 and 2. But they're always coordinate points. It's not fractions, okay? It's nothing fancy like that. It's just a coordinate point and I'm good to go. So here's what I want to do on this third one. I'm going to give you the equations. I want you to try graphing them and seeing if or when they cross. So my first equation is going to be y equals 2x plus 8, because I add my 2x over. And my second equation is going to be y equals negative 2x plus 4. So like I've done in the past, I'm going to cover the screen up here for a second. I want you to try using these. Just try something. Try to graph both of these and see if you can find the point where they cross over with each other. And then I'll kind of walk around a bit, kind of see how it's going. And then I'll uncover it here in a minute, and we'll see if we found the right spot or if there's something else we need to play with a little bit here. So go dot crazy. Make sure you're getting your dots in on all of those. Uh-oh. My marker's going bad. Switch colors. Color's not showing up well either. All right. Again, keep dotting until you find that point that both lines have in common. Because once you do, and they do have a point, I'll give you a hint. They absolutely have a point that they share. So take a moment, just even if it's just you're graphing the lines and maybe the intersection point is what's getting you. I can help figure some of that out, but I got to be able to figure out where we're at before we can do that. Probably should pause this for a moment. I've got several of you. Shh, bring it back in, because unfortunately this is how some of you got yourselves in dilemmas before. I know. So what we're going to do here, some of you may not have necessarily had the correct answer when I came around, but it was for other little details back in the equation, not that you couldn't graph the lines. So again, when you're doing these, the focus is going to be take your time, one, and number two, that you're actually practicing enough to get better at it. If the only time you're writing something down is when I'm doing them all up here and then you throw your hands up, you're not going to get better at it. That's not how it works on anything. So what I want to do, because I have a feeling this may give some of you a little more incentive to be working along here, and we've got some good examples on here, I thought just maybe I'd work through some of the homework ones with you, just to kind of get you a head start and maybe, just maybe, get you that little bit of incentive to work through those. So I'm gonna come over to here. This is the homework. So for homework check, because we're working on homework check 2 right now, this would be the second assignment that we're working on with this. So I am going to help out with one question on the front and one on the back. To give you a heads up, you do not have to do the little puzzle that's on the back. As long as you can get to the answers and graph your lines, I'm fine with that. But you do have to graph your lines even if You can do it in your head. You're great at this. Fill in the blank with whatever other thing it would be. So, what I want to do is I want to take a peek here on the front with you at number 2, and then we're going to flip over to the back. And there's a couple back there where we still got to get the y by itself that I want to work on, because I think that may be what's getting some of you. You look at that top equation, you're like, wait a minute, x equals -5. We talked about this yesterday. If it's just x equals in a number, remember, here's my x-axis. Which direction do I go to get to -5? Yes, I agree. We're going to go left. I'm going to go left 5, and I'm going to put a dot. Once I do that, whenever I get an x equals, I'm just going to draw a vertical line through that dot. Okay? That only works with x equals. If it's y equals, it goes the other direction. Okay? But if I don't have it looking like a normal equation, that's what happens. My other one, though, is normal. My other one, I do have a y-intercept that I can go ahead and plot on the y-axis. What direction would I go to plot that -3 for my y-intercept? Down. So I go down 3, make me a nice big dot. And when I don't see a number in front of x, what's my slope going to be? 1. So my slope for this one is 1/1. In other words, I'm going to go up 1 and right 1. And you might start doing this. You're like, again, Harty, wait a minute. I'm going up and right. That's not getting me any closer to that other line. You know, you're right. Why am I going to keep going up and to the right if it's not getting me any closer? So what's my opposite again I could do? Down and left. So down and left, down and left. Okay, now we're closing in. There we go. Okay. So right there. There is my point. But what point is it? If I start back at 0, how many did I go left and how many did I go down to get here? Anybody? I went down 8, okay. That takes care of this part. Now how many did I go left before I did my down 8? 5. So I started 0, I went left 5, down 8, there's my point. That's my answer that I'm looking for. That is the answer. So when I'm doing these, I've got to graph the lines, but then I still have to be able to figure out how to describe what that answer is going to be. Yeah. You would put plus zeros on both of those. I agree with you. If there is not a number after your x term, you always can put a 0 in there. That is an excellent question. So our last one, at least that I'm going to do, last one. So we're going to flip over. Oh, what looks like fun back here. What do you think? Number 10? I think so. All right. So here's our deal. Stick with me, especially those of you that are kind of in and out on me. Job number 1. Get y by itself if it isn't. Only if it isn't. Sometimes it will be. How do I get y by itself? How do I get that minus 2x out of there? Add it. Now see, I got my equation experts out there that are willing to talk to me. We just got to make you graphing experts now. Okay, because I always want my x first. So this is my first line. What's my y-intercept in this first line? 1. Big dot on the y-axis where y is 1. So if that's my y-intercept, what's my slope then? 2 over 1. And what's that mean? Yes. Now we're getting some speakers. Up 2 and right 1. Up 2 and right 1. Go dot crazy. And when you run out of room, we just do our double opposite. So instead of up and right, we're going to go down and left. Down and left. Down and left. Oh, I am off the screen. Thank you, sir. Doesn't do us much good if you can't see what I'm doing. And left. So I've got this first line, my y equals 2x plus 1 done. So I've got one more job left to do here. I'm going to rewrite this. See, there's a little more room on this sheet. We can work a little better here. Again, job 1, get y alone. How do I do this? Add the x. So whammo there. Again, put the x term first, because that keeps us out of trouble. So I've got my equation. Where's my y-intercept? Number on the end, -1. Big old dot. So what about my slope? 1 over 1, because again, if there's no number in front of x, we assume there's a 1 there. So, going up 1 and over 1. Oh. And I'm starting to look, and I'm like, uh-oh. This is getting further away from that line again. I don't think going this direction is helping me much. I agree. So instead of going up and right, we're going to go down and left. Down and there's my guy right there. Right there. Right. Ooh, I'm hearing good things. I heard -2 coming out of my mouth already. I like that. Left 2, how many down and we're good? 3. -2, -3. We have ourselves an answer. And the cool thing is when you're doing these, when you get an answer, you've kind of got a key here to work with and say, okay, is this answer here? Yes, that's my answer right there. And kind of work it. So reminder again, this one that we just did a couple on, this is the homework. This is the one that when we do our homework check next week, that'll be coming in as the assignment for what we're doing. So if you're kind of still playing around with yesterday's, maybe you get this one a little bit better now and can try it. But that's what I'm going to keep stressing. You've got to try something, even if it's wrong. Try something, because we can always fix wrong. We can't fix nothing.